Okay, everybody, welcome to week 7 material. We're going to be covering two major topics this week. That is LODs and an introduction to animation within Unity. First things first, we're going to cover LODs, and we're going to do that within Maya first and foremost. We have this teddy bear model here. Important to note, I did not make this model. The credit to that goes to Professor Boyle, who generously gave me this model for demonstration purposes. So thank you very much to Professor Boyle. Yeah, let's talk about LODs. So they were brought up very briefly in week 5 material when we were creating our terrains. Essentially, some of the trees in some of the asset packages that we were using had a built-in LODs wherein when you were really, really close up with a camera, the trees would be very detailed, and when you were far away, the trees would be less detailed to save space and to ensure a smoother game engine experience. That is a very important thing in game development and game engine experience. Level of detail, essentially. To save on frame rate and improve overall performance, you want to make sure that when the camera is up close to something like this teddy bear, it's high quality, high model, high poly, as so. And when it's far away and you can't really make out all the specific details, there's no reason for this bear to have, this many polys. And in fact, let's look at how many polys this bear actually has by going up to display, heads up display, and poly count here. And we can see that this bear has specifically 4,032 faces. By the way, this column here is the total amount of faces in the entire scene, and selecting an object gives you how many faces that one specific object has here in this column. So 4,032 faces. In reality, this particular model is not that heavy duty, and you can probably get away with putting this into Unity with, none or only one or two, or only one extra level of detail modeled. But for the purposes of this demonstration, we're going to act as if those is a very, very heavy duty model, and we're going to reduce the poly count on it. So let's go ahead and zoom back into the bear, and let's go ahead and let's rename it first of all, because we're going to be working in a very, very specific manner to accomplish what we're doing here. So we're going to name this Teddy LOD00, and that's okay. And now we're going to go ahead and we're just going to move it over, and then I'm going to Control D. I'm just going to make a copy right there. Now, there are two ways to reduce the poly count of a high poly model like this bear. The first way is very simple, very automated, and if you're low on time or trying to meet a deadline, then it's probably the best way to do it. And that is very simply by just going up to Mesh, by going to Reduce, the options for Reduce specifically. I'm going to drag that in here. We're going to make sure our reduction method is percentage. We're going to make sure we have it just at 50%. We don't want to go too crazy with it, and we're just going to reduce. And there we go. There is a lower poly version of this teddy bear. As you can see, this teddy bear now is only 1,986 faces, 1,986 polys versus the 4,032 polys here. And we can further reduce for another lower level of detail by just copying again and moving it forward. And again, we just go up to Mesh. Again, we just go to Reduce, Options, make sure we're at 50, we reduce. There we go. Again, that is the very, very fast way to reduce the poly count. As we can see now, we have less than 1,000 faces, as compared to the nearly 2,000 here and the over 4,000 here. We can play with the settings here to further reduce the poly count. I mean, this might be a little bit too extreme, but there may be instances where something like this is probably going to be useful for something, at least for a mesh collider, which we can discuss towards the end of this particular video. I'm going to go ahead and put this back at 50. Type in 50 exactly. There we go. Okay. So that's the fast way to reduce the poly count of any given asset, right? And again, if we zoom out the camera, we can see that there's no real difference between the bears from a distance. So using a low poly version of the model from a distance is really, really helpful, and using a high poly version of the model from close up is, ideally better, because from a distance these all look exactly the same. So it's okay that this one has so much fewer faces than this one, and when you're close up, you can just use the high poly one because this is the best looking one overall. So that's the automated way of reducing your poly count. The quick, easy, dirty, automated way. Now I'm going to go ahead and speed run through the manual way because, just bring them back. These are a little bit rough, and we can probably do a little bit better in regards to keeping the overall form of the bear while reducing the overall poly count. And I'm going to show you how right now. Again, I'm not going to talk during this part because deleting vertices as like this, just selecting edge loops and holding shift to select multiple edge loops and then going up to edit mesh and then going to delete edge vertex again and again and again is a very, very slow process and a very, very, laborious process that has its place and it can be quite fun, but there's not much to talk about aside from the fact that we're going to be deleting edges. So I am going to speed up, and when I come back, we will have a much lower poly version of this bear. Okay, quick cut. In between the cuts, I went ahead and just did another automatic mesh reduce of this high poly one, so that we have this automatic version of reducing the poly count and this manual version of reducing the poly count. As you can see by my history there of all the edge loops that I was deleting throughout the model. As you can see, there is a difference between the quality that you can get if you manually reduce your polys versus if you if you let Maya automatically reduce your polys, Maya or Blender. Ultimately, what you end up doing depends on how much time you have. So if you have more time on your hands, be sure to manually reduce because you get better results that way, as you can see. And if you have less time, then make sure to automatically reduce to, save on time. And because, if you're in a rush, this version here is good enough. Though, again, you can retain more of the form if you manually reduce. Not only did we better retain the form, but we actually have a lesser poly count here at 1,500 faces versus the automatic reduction, which has 1,900 faces. So not only does it look better, but we have less faces here than we do here. So again, manual is better if you have the time. If you don't, you want to go the automatic route. So I'm going to go ahead and delete this because we're not done yet. I have the level 1, the super close-up version of the bear. Level 2, which is going to be the bear when you see it from further away. And we're going to have level 3, one more version of the bear where you're going to be seeing it from really really far away. So it's going to be a much lower quality version, much lower poly version. So I am going to cut again. I'm going to speed through deleting my edge loops because again there isn't really much to say. I'm just selecting edge loops and deleting them. Specifically though, I should say I am, instead of just pressing the delete key, I am going up to edit mesh and deleting edge vertex. You want to make sure you delete your edges and vertices this way, otherwise the model is not going to recognize that the edges and vertices have disappeared, so you get some really weird results that are difficult to clean up if you don't delete your edges and vertices by going to edit mesh and then delete edge vertex. So I also had the UV editor open because this model has already been UV unwrapped, and I wanted to make sure that these lower quality versions, if for whatever reason I decided to use a texture for this bear, that I could use the exact same texture for every single version of the bear from high poly to lowest poly to ensure that I wouldn't have to double up on my work or anything like that. So now I'm going to go ahead and cut. I'm going to reduce the poly count of this bear, and then we will take it all into Unity. Okay, and this is the lowest poly version of the bear yet. At this one, we only have 346 faces compared to the 1500 here and the over 4,000 here. From a distance, the bears are all equatable. There's not any real difference to each of them from a distance. From close up, it becomes more obvious. But again, once we get into Unity, we will be able to properly see how the LODs operate. Just how they operate in general, similar to the trees that we saw in week 5. So let's finish our prep work in Maya and then get all this into Unity. We don't need the UV editor anymore. Let's go ahead and let's get all of these back to 0.0. We want to make sure these are all right on top of each other. So that's 0, and this one is 0. Good. Next thing we want to do is we want to group them. So I'm going to select all of them and press Control G. I want to call this Teddy LODs. Sure. There we go. And what else? Oh, we need to delete all the history, of course, for the group and for everything inside of it. So we need to make sure not only that things are named properly, which thankfully, since we named the original one Teddy LOD00, the subsequent ones are, properly named 01 and 02. We need to make sure the history is all deleted, otherwise things get weird once we if we start doing any more stuff to them. So let's go ahead with everything selected. We're going to go to Edit, Delete by Type, History. Do I need to do anything else? Modify. I don't need to freeze the transformations because they're all at 0. And I don't need to center the pivot because I like the pivot down here at the feet. All right. I think the only other thing that's left to do, really, is to scale it up. Because, again, Unity and Maya will operate on different scales, so I don't mind if this becomes a little bit bigger. Not that big. Want to make sure that that it doesn't overtake the rest of the scene. So that's a decent size. And actually, since we went ahead and did that, let's freeze the transformations again. So make sure everything's scaled at 111. Everything's proper here. Okay, great. All right. So all we have to do now is select our group. We are going to go to File. We're going to Export. We're going to export as an FBX. Yes. Good. Embed media, that's fine. There's no textures, but it doesn't matter. We're going to put this in the desktop, and I'm going to call this... actually, not in the desktop. I'm going to create a special folder. A new folder, I'm going to call this LOD Models. There we go. Moodles. There we go. Models. And I'm going to call this Teddy LODs. And we're going to export. Okay, let's jump back into Unity and actually get this in there, shall we? Hello, this, by the way, is the scene from the end of week 3. Didn't make any changes except that I added a mesh collider to my bench here. We'll talk about the colliders in a little bit more in a little bit. But first, let's go ahead and actually get the bear in here. So, assets. Where do I want to put this? I guess, for the sake of the demo, I'll just make a new folder. So create folder, LOD models. In here, we're going to import the new asset from the desktop. LOD models folder, Teddy LODs. Here we go. Okay. And now let's actually just get this into the scene. Should be an okay size. It's very small, but it's okay. As you can see, because we did the work of properly grouping the bears from high poly to lowest poly, and we put them all in a group, Unity automatically recognizes that this is the level of detail situation. So let me just go ahead and scale it up so we can properly see it a little bit more. Unity recognizes this is a level of detail situation and automatically adds the LOD group into the Teddy LOD's inspector, not in the individual teddies, not in the individual teddy bear models, but in the group inspector. It adds this LOD group component here, which we'll talk about in a bit. First of all, we can see if we just select the teddy bears individually, that we can see the high poly version, the middle poly version, the lowest poly version, and here in the big group we have the LOD group. So the way the LOD group works, you can test it for yourself, either by selecting the camera directly here, which fades everything else out in Unity. You can just test out for yourself when the models when the model changes from the high poly to the middle poly to the lowest poly till finally it's just gone. Or you can just use the regular camera here, or just play the scene for yourself. It's kind of difficult to tell when the jump happens because we did a pretty good job of lowering the poly count to not sacrifice the form that much, but it is happening, and we can see it better if we actually create materials for this. So let's go ahead and create material. I'm going to call this high poly matte. I'm just going to make the high poly matte red to make it very clear. I'm going to create another material. I'm going to call this mid poly. I mean, not that kind of mid, just middle, the non-rude version of mid. And finally, we're going to create, I think, a blue one. Low poly matte. We're going to make it blue. There we go. Okay. And now we're going to apply each of them to the individual bears. So let's see. I want to edit. Want to take the high poly, just add the red there. The middle poly, add the green there. And the low poly, add the blue there. Okay. So now if we go back to the camera here, we can see when we're up close, we have this high quality version of the bear, and when we get further enough away, it's going to make the jump into... What happened? Where is my green? There we go. Yeah, is this one still blue? No, it's not. Why not? Oh, I see. That's weird. Okay. So let's just add it in this way. Mid and low. Mid and low. There we go. And make this red again. There we go. Okay. That should fix it. There we go. Adding the materials here throughout the inspector instead of directly onto the scene, I guess, was just a little trick there. It's fine. Anyway, as I was saying, now that we have these three distinct materials, we can very, very clearly see when the jump happens. So we select the camera and we zoom out. Eventually, it's going to jump to green because it is jumping from the high poly version of the model to the mid poly version of the model, and finally the lowest poly version of the model, and then it's finally gone. We can't even see it because it's so far away. That is how LODs work. That is the basic way that that's the basic way that level of distance works. Again, smartly setting up the groups here in Maya makes it so that we don't even have to find the LOD group component in the inspector. It automatically adds it for us in the in Unity. But in another video, I'll show you how to manually add this if you're interested in manually adding this within Unity to something. So the last thing I want to cover really, really quick is just colliders again. So for this bear, I'm going to go ahead and add a component. I'm going to add physics. I'm going to add what? I think a capsule collider will be okay for this. So let's go to capsule. We can lower this. And we can also add a rigid body. So they're both under physics. Let's go to rigid body. There's the rigid body. Nice. Okay. I don't think we need to really do anything else. Let's go ahead and just play the scene here and get a sense for how the LODs work once we're actually in the scene. Here we go. Oh, hey, the bear's floating. Why is the bear floating? That's strange. Let's go back in here. Okay, everybody, big cut. I went ahead, I couldn't for the life of me figure out why the Chivolo guy couldn't interact with the rigid body of the teddy bear. I think it just has something to do with how that particular asset package was made. I added extra scripts to it and everything, and it wasn't working, so I just made a blank scene with the bear and with an FPS controller that I made for week 3 material. And I attached a brand new script to it, so aside from the basic FPS controller script that we did for week 3, I also attached something called the Collider script. I am going to put up the Collider script for you in Moodle so that you can have access to it. Very useful. Allows you to just interact and push rigid bodies that the character comes in contact with. Very useful. Again, I'm going to put this up in Moodle for you to have access to whenever you'd like. All right, so what I do to this, all I did in this new scene was add a plane, add in the teddy bear, add in a capsule, collider, rigid body, all the basic stuff that I did before. Real quick before we play the scene, I want to stress that you can actually play around with the LOD group specifically. So you can play around with the distance that it takes before the model shifts from the high poly version to the middle poly version to the low poly version to disappearing completely. You have the power to control that a little bit if you want to right here, or here under object size. You can play around by just playing around with this particular number here. All right, so let's go ahead and play the scene because now we have a capsule collider and a rigid body. We should be able to interact with this thanks to our scripts for the first-person camera. We get closer, we get the highest poly version, middle distance, middle poly version, furthest distance, the low poly version. But again, we're so far away that you can't really tell that it's a low poly version aside from the fact that the colors that I assigned it before, give away when the jump happens. But it's a very smooth jump, all things considered. I really like it. Let's go ahead and push this to the ground. And because it's capsule collider, the capsule is an invisible mesh that is overlaying and on top of this teddy bear. We can treat it as if though it was a capsule, which is great. But the final thing I want to show you is the mesh colliders. We did mesh colliders very briefly in week 3, but I'm going to I'm going to show them again here in a little bit more detail. So we don't need the capsule collider anymore. Let's get rid of it. Let's add physics. Let's go to mesh collider. There it is. Let's put this up here for organization's sake. Very good. We want to make sure we check convex when we use a mesh collider. Okay. So the way mesh colliders work, we can essentially, this by the way is a little spoiler for a little bit later, we can essentially just take any asset that matches up what our bear looks like here. In this case, I'm going to take the highest poly version, and I'm just going to attach it. And we can play the scene. And now the bear should behave a little bit more realistically when we come in contact with it. And, you know, since it's very top heavy, it's just going to topple over to the ground, as that makes sense. And we can push it around. Again, it's not going to roll like a capsule. Now it has an invisible bear mesh overlaid right on top of the actual visible bear mesh. And we can push it around and treat it as if though it was an actual bear, as if though it was an actual teddy bear with more realistic interactions, which is all well and good, but we are using a high poly version of the model. This LOD 00, I believe. This is the super high poly red version of it, which is fine. Technically, it works, but because it is such high poly, you're basically sacrificing a little bit of performance for no reason. What you could do instead is go back into Maya and further reduce. Oh, didn't want to copy. Shift H, there we go, and further reduce the lowest version of the LOD that you have. In this case, this one. I went ahead and just went to mesh, reduce the options here, reduced it by 50% again to create this final version here. And you know, this final version, as you can see, matches up with the shape, you know, almost perfectly. But it's super low poly at only 140 faces, so it's not going to sacrifice performance at all to make this the collider for the bear, which is exactly what we're going to do. So let's go ahead and go back. I already went ahead and exported the collider, but basically what I did was just file, export the selection, this little one right here. We can overwrite it if we want to. Export selection. I'm not actually going to overwrite because I already have it in Unity, but and just saved it as Teddy Collider. We open up Unity. I went ahead and imported it in here, and now we can go ahead and replace this high poly mesh collider with this super low poly mesh collider here that matches up with the shape anyway. And when we play the scene, you'll see that we get the exact same results that we did before. Again, bear should topple over because it's very top heavy. We can push it around essentially just as we did before, with no sacrifices to performance. So that is a brief video on how LODs work, how you can automatically make them, how you can manually make them, and how they can automatically be used within Unity. In the next video, I'm going to do some more with LODs, specifically manually set one up and just do a few more examples of them to show the power of LODs in general. So that's it for this video. I hope it helped. Thank you very much for watching.